The Indian Space Research Organization successfully conducted the second landing experiment with its ambitious reusable launch vehicle Pushpak on March 22, 2024. Pushpak, adapted from the epic Ramayana, aims to not just launch mission to space but also return the same way as the American shuttle mission. The idea is simple: democratize access to space and make it cheap. To ensure it, the Indian Space Agency has been focusing on developing indigenous technology in the form of the RLV. The Pushpak mission is the part of ISRO's border strategy to develop a fully reusable launch vehicle which could slash the current cost of space access by a strategic 80%. Currently, launching a kilogram of payload into space can cost between $12,000 and $15,000. The vision is to reduce this to $500 to $1,000 per kilogram, employing a two-fold approach, making system recoverable and reusable and adopting more efficient propulsion systems such as air-breathing rocket. The RLV program focuses on three key areas: powerful engine, surviving re-entry and safe landing. First is the Scramjet engine, which unlike traditional engine uses the vehicle high speed to compress incoming air, eliminating the need to carry a heavy oxidizer. This not only will reduce the lift-off mass of vehicle but also the cost. The first experimental mission of ISRO's Scramjet engine to validate the air-breathing propulsion system was successfully conducted on August 28, 2016 from Satish Dhawan Space Center, SHAR, Sriharikota. After a flight of about 300 seconds, the vehicle touched down in the Bay of Bengal, approximately 320 km from Sriharikota. It is used hydrogen as fuel and oxygen from the atmospheric air as the oxidizer. One of the biggest challenges in the space exploration mission remains re-entry into Earth's thick atmosphere. Re-entry heat management has remained a headache for space agencies across the world. Safeguarding Pushpak during its firing return to Earth atmosphere is crucial. ISRO is testing heat resistant materials and re entering profiles to ensure the vehicle survives the intense heat generated by hydrosophic travel. In May 2016, a test flight reached an altitude of 65 km and re entered the atmosphere at hypersonic speed, validating the RLVS design. As the vehicle will be operated autonomously, landing safely on the three gears is paramount. The vehicle will act like a glider as it approaches the runway, and the system should be precise and to the point in making that pitch perfect landing. On March 22, 2024, the RLV landing experiment LEX showcased the third crucial aspect of this vision: autonomous landing. The experiment was designed to test the vehicle ability to handle off nominal condition, that is scenarios that deviates from the expected path. Pushpak was released with the induced anomalies to evaluate the robustness of its navigation, control, and guidance mechanisms. The Pushpak successfully demonstrated its ability to autonomously course correct and the land. These technologies include the state of the art navigation system, a pseudo light system acting as a ground based GPS alternative, a KA brand radar altimeter for precise altitude measurements, an indigenous nav IC receiver, and an innovative landing gear system. Additionally, the mission used aerofoil honeycomb finds and the brake parachute system for controlled descent and landing. The Pushpak mission represents a leap towards making a space exploration more sustainable and cost effective. By demonstrating the reuse capability of flight hardware and system, ISRO has shown that it is possible to conduct space mission at a fraction of the cost. Looking forward, the RLV-TD program is set to undergo further experimental flights, including the orbital return flight experiment and the Scramjet propulsion experiment. These experiments will pave the way for the development of the two-stage orbital launch vehicle, which aims to deliver payloads to their intended orbit more effectively. The current winged RLV will wingspan of 3.6 meter and an overall length of 6.5 meters is planned to be scaled up by 1.6 times for the first stage of this reusable orbital launch vehicle. The RLV's design, featuring a low cost lift to drag ratio, is optimized for high speed, high angle approaches and landing at velocities of up to 350 km per hour. While a high lift to drag the ratio is generally preferred for fuel efficiency in aeroplanes, a lower ratio is advantageous during landing, allowing for a controlled descent and safe touchdown. Pushpak is incrementally headed towards becoming a reality as India open up the space for the world.